Okay, let's continue our slide. Okay, we are now in T06 and we're talking about logistic regression. Okay. As we mentioned before, we would like to have a shape, Z shape, okay, to fit our data, okay, our binary data, binary target data. So it looks like this. However, there is a very important assumption right here. Okay, I would like to make sure you notice that. Okay, this one. Note that we assume Z is linear to X, which is your feature. Okay. Since the function is like this, right? Fz equals 1. Okay, that is this shape. Okay. However, we have a lot of features, right? So what is the relation? We know currently that is the relationship between Z and Y. Y is our probability to win, right? And Z is this function. Okay, this sigmoid function can appropriately fit the data. However, what is the relationship between Z and our feature X, big X? Okay, in here we assume Z is linear to our X, so that we can write in this way: Z equals to AX plus B, or any other form such like theta 0, theta 1, x1, or we simply just write theta x or something like that. Okay, that's all okay. So that is an assumption. Just exactly in linear regression we say y is linear to x. It is an assumption. It is an observation, right? So here in logistic regression, we simply just assume the z value is linear to x. There's no any reason. You can even define your function, which is nonlinear, to describe the relationship between z and your x, your features. But for simplicity, we just, okay, we have learned linear regression, so linear looks good. So in this z shape, okay, when we describe the relationship between z and x, we still use linear relationship to describe their relationship. Okay, so it is an assumption, just like you assume what you assume in linear regression. Okay, so of course you can assume any other nonlinear, but we just simply assume linear relationship right here. So it looks like this. Okay, so currently we'd like to find what is the best parameter of x, best parameter, okay, a star, b star. Okay, try to fit the curve. Okay, so first, the question that we'd like to ask is, what is the possibility of y equals to 1, which means win, if we have x equals to x, which I mentioned before, right? And currently the x is can be a single variable like score, or can be multiple variables like score, touchdown you have done, how many yards you run, something like that. There could be a lot of different features. Okay, we simply just use a big X to represent all the features. Okay. Given the training data, we find the best curve. Okay, assume there's a function with parameter f theta. So there should be an optimized theta star. Okay, which all the parameters including w star and b star, or a star, b star, or theta star, b star, which is okay. Okay, so now the curve looks like this. All right. Okay, I would like to tell you what this is. Okay. Usually when we say, okay, theta 0 plus theta 1 x1 plus theta 2 x2, something like that. Okay. However, when we do the calculation, usually, okay, we use matrix 啊，或者是中文就是行列式，或者是矩阵嘛，哈。So usually we write it in this way, okay? x1, x2, x3, x4 to xn, all your features. Okay, you will put these features right here. So that is called x, right? We simply just use this, okay? So you need another parameter to represent theta, right? So basically theta is like this. Theta 1, theta 2, theta 3 to theta n. So that is theta. If you write it in a matrix way, 如果你用矩阵的写法的话，我们就不会把它乘开的 ，OK？ But however, this matrix cannot be product， 就是这两个都是直的嘛。我们这行列是一个你要做 product， 一个要是横的嘛，一个要是直的嘛，对不对 ？So basically, we use this notation, theta transport dot x. We use this notation to represent theta 0 plus theta 1 x1 plus theta 2 x2 plus until theta m. Okay, we use this notation. It is a matrix way to represent the underlying function. 好，就是我们要用我们语义上是乘积的和嘛，对不对？但是我们写成矩阵或者行列式的时候，因为直的跟直的不能相乘嘛，所以那个 t 一定要写。好，那 t 就只表示转置矩阵。好 ，the big T represent transpose 啊，就是 matrix transpose 啊，这样才有办法乘啊。所以后面看到这就不要疑惑了，反正它就是积的和的意思嘛。好，这个我想大家应该会知道。OK。So let's just remove these things. So basically, when you see theta transpose product x, it just simply represent, okay, the sum of the following items. Okay. Okay. So basically, we like to find the curve. Okay, the curve has a best parameter called theta star, which is right here. It's right here. We would like to find the function. The function looks like this, right? Which is a sigmoid function. It's a Z-shaped function. Okay, and there should be a optimized parameter, theta star. Theta star means theta 0 star, theta 1 star, theta 2 star, theta 3 star, theta n until theta m star. Okay, so theta star means a collection of all optimized parameters. Okay, so we like to use this shape to approximate. Okay, 就是这个是 approximate this value. So the definition is right here. To find the optimized parameter in sigmoid function, so that the y hat, which is 1 over 1 plus e minus z power, will approximate the probability we want, which is probability of y equals 1, which means win, under the condition given all big X, which is your features, and the result will be y. So we're going to do such kind of approximation. Okay, I would like to explain it in Mandarin again. 我们要做的事情呢，现在就是找到一个很棒的 Z 长得像 Z shape 的这个函式。那这个 Z shape 函式里面有一些参数，就是 theta 星，啊，那是最好的西塔星。那西塔星呢，就是它的组成就是西塔0、西塔1、西塔2、西塔3、西塔4、西塔星5星嘛，啊，就是所有的星组在一起。它们的值呢就是 y hat 嘛，就是 predict 就是 y hat， 啊，所以它的形状啊像这个样子。那我们是assume说下面那个 Z 值呢应该是 X 的一个线性的组合嘛。 那这个 z 的 function 要 approximate 什么呢？要 approximate 右边这个我们真正想要做的事情，就是当 probability y 是赢的时候 ，under 什么 condition 呢？就是那一场比赛所有的 feature 都丢进去，好，就是 big X， 就 under 你知道那个 condition 的时候，那它真正的答案是 y， 就是赢或输。那我们要让这个 y hat 跟 y 要很靠近，我们做 approximation。那里面所有的值都有 ，x 也会有 ，y 也会有，因为你有全年 data， 所以你会有所有的值。那你要怎么？那你要找到最棒的 A 跟A 星 B 星嘛，就是现在所谓的西塔星，去让这两个 y 跟 y hat 要很靠近，就是那个波浪号，就是 approximate 这个东西哦。OK。So if the definition of this problem is like this, so make sure you notice that, okay? If you use 1 to minus the best function you would like to use, 1 minus f of x under theta star, okay? So the answer is y minus, I clean it, okay? Make sure you can. Okay, so it equals y minus y hat, 1 minus y hat, that's the definition, right? So basically, you just put it right here, okay? You use 1 to minus this value, okay? It becomes this one, okay? And by definition, it is under the current feature you obtain, the data you obtain. How possible you lose this data? Okay, that's the definition because you use 1 to minus y hat. Okay, so it is. Basically, this definition is the same. Okay, just the above one describe how do you win. The bottom one describe the probability you lose. But basically, you add these two values, the sum will be 1 啊，因为你不是赢就是输嘛，对不对？所以你用1去减它，就是把它反过来啊。So the next question is, since we have y and y hat, then we have a measurement. We need a measurement, which is a loss function, to help us to find those optimized parameters. But how? In linear regression, we use MSE, and we minimize the MSE to find the optimized A star and B star. So can we do the same thing right here? The answer is no. We need another function. Here's the reason why, okay? Let's see, the loss function, okay? So that is the definition, right? Which we use it now. So with this definition, actually, okay, there are two formulas, right? But basically we can combine them together. So look at carefully, okay? Look at quite carefully. Since y is a binary value, so it can be only 1 or 0. So if we eliminate this one, so write it in this way. Take a look. If y currently is 0, so what is the later notation become? Okay, that becomes f theta x. Currently y is 0, right? So the power by 0. Okay, 1 minus x. That is 1 minus 0, so that is 1. So basically that is 1, right? No matter what it is. So this result is exactly the same as when y is 0 right here. Right. So another one, if y is 1. So currently f theta x power 1, right? 1 minus f theta x, okay? 1 minus 1. So this item becomes 1, right? So that is f theta. x. So that is exactly the same as this one. So we can simply just combine the formula at the top, these two, by using just only one formula to simplify this representation. Okay, they are exactly the same. Okay, if you put y equals 1 or y equals to 0 in the formula. Okay, so currently our problem becomes this. Okay, it is quite easier if we deal with only one equation rather than use two. So that is the equation we'd like to deal with. Okay, so basically we would like to calculate the likelihood. Okay, what exactly the likelihood is. That means you use this formula right here. Okay, and you simply take the product across all the data. For example, if you have a data like this, okay, okay, 0 to 1. The first data, the second data, and you have n data, okay, and you have x right here, and you have y right here. Okay, what is the likelihood xy, which is right here? What does that exactly means? That means you product everything, right? So that means you product everything. And that is the likelihood of this data. Okay. What likelihood means? Okay. And theta x. Okay. So that is the original data you collect. This is your feature. That is the result your data, which is your target. So it's win or lose. That is the estimation data you it estimate value by using this x by using the x value here. Okay. So the likelihood is like that. Okay. If that is lose, lose, win, win, lose, something like that. Okay. And at the right hand side, which is your estimation? Which is your estimation of your model, right? So maybe, okay, I just say maybe the result like this, okay? It says, okay, from my model, okay, which is an unknown model, my prediction is it has a very low possibility to win, okay? And that is even lower, okay? That is higher, for example, 80%, higher, 75. Something like that. There's a model, right? And it has its estimation based on the features, based on the training data. The feature of the training data we collect, okay, to get this value, okay? So basically, the likelihood is that we would like, how do we measure such kind of model? So basically, okay, if it is a linear regression, we simply just subtract y and y hat, right? Y and y hat and do MSE. However, right here, we cannot do that because we would like to let the y hat, for example, this one. We would like this value to be very close to 0, and it would be better, and it is 0. Okay, you can think it in this way. If this model says, okay, this value is 0.2, okay? But do you think it is lose or it is win if it is 0.2? You don't know, right? But it is close to 0, so we believe, okay, that means it has only 20% to win this game. However, when you do the gradient descent 当你做那个 gradient descent 的时候 0.1 and 0.2 is nearly indifferentiable 就是你在做 gradient descent 的时候，这个 y hat 的值是 0.2 还是 0.1 其实都不是你想要的，你想要的是它要很靠近你真正的 y 是0，可以吗？好，所以呢，如果我们用 MAC 来评断的话，它会慢慢的下降，就是比如说原本是 0.2， 然后跳到一个新的 A 星 B 星现在跳一个新的 A B， 它变成0.19、0.18、0.17， 然后就慢慢靠近最低的值嘛，但它终究不会靠近0的。所以在这边，我们觉得 MAC 不是一个很好的方法，我们需要一个更激进的方法，它直接的跳到0，在1跟0之间做选择，这样会比较好一点。好，我要用英文再解释一遍哦。In logistic regression, okay, the value when we do gradient descent, okay, the value maybe starts from 0.2, and it will gradually decrease. For example, 0.19, 0.18, 16, 17, 15, 0.10, 9, 0.09 until. However, the gradient descent process is too slow, and we would like to the value, okay, to be aggressive, to be either 1 or 0, because our y value is a binary value. It should be 1 or 0. We don't want to do gradient descent slowly, okay? So basically, we should design another loss function, another measurement to help us to fastly decrease the current y hat to either 1 or 0, not something between 1 and 0. Okay, so basically we use another thing, which is likelihood, to describe this. So how do we do that? Ideally, it looks like this. We do product. Okay. For the first item, okay, you simply just look at this one, this formula, okay. The first item is f, right here, f theta x y times 1 minus f theta x y minus 1. What is that? This one, which is 0.1, right? And the y is, sorry, it should be power. What is y? Y is right here, 0, right? The right hand side should be 0.9, and the power is 1 minus 0 is 1. So that is exactly the likelihood for theta 1. Okay? The likelihood for theta 1. Okay. If y hat is very, very close to y, for example, if there is a y right here, 0, and there is a y hat right here, which is 0, okay? Then we take a look at this one, okay? 0, 0, right? And the other one is 1 minus 0, 1 minus, which means that is 1, right? If In a binary classification case, if your target is a binary value, category value, binary case, and so if they're exactly the same, this function shows that okay, they are the value should be one. 好，再讲一遍哈，在一个 binary classification 就是 y 是0、1变数的这个情况之下啊，如果你的表格长像右边这个样子，然后是绿色的那个值的话，好，假设两个都是0的话。你把它带到那个 likelihood 的公式里面的时候啊，你会发现它这样子乘出来啊，刚好就是1嘛，对不对？刚好就是1哈。好，那我们看另外一次 ，even if you think you use another one, which is 1 and 1, okay, what is the value of this one? 怎么写 ？1, 1, right? 1 minus 1. 1, and the answer is still 1. So in this way, the likelihood, it looks like it can tell us if the y and the y hat is different or not. It has a certain kind of measurement. If it is both 0, like the green line, okay, then the answer is 1, the green one. If both of them are 1, magically, okay, the answer is still 1, purple, the purple one. Okay? However, if the y and the y hat is not identical, 它们是不一样的, then we will have another, we will still use this function. Okay? So the answer would be 0.9, which means the y is 0 and y hat is 0.1, and they are different, and we have a measurement. The number is 0.9. So among n data, okay, among all those n data, we calculate this value for all these n rows. 就是在我们计算整体的时候，就是对这整个 n 个 rows 去计算这个值嘛。And what next? Right here. We do multiplication， 就是我们做乘法，我们把后面那个值全部乘起来。So that is a very aggressive measurement。它是一个很激进的这个我们所谓就是我们在比较 y， 就是这个 y hat 好像有个模型嘛，它会输出 y hat 嘛，我们比较这个 y hat 跟 y 到底有多么的像或不像。这个很激进哈，因为很像的那些 rows 它就是1嘛。可是不像的那一些啊，可能就是什么0.9、0.8、0.7啊，对不对？那我们怎么做呢？我们是把它全部 product 起来，是乘法，所以最后就会乘出一个数字出来。那这数字很可怕，因为你越不像的话，你要想，你看，你就算每一个不像的都0.9，那你就会变成是0.9乘0.9乘0.9乘0.9，你就一直乘那个0.9下去。那我们知道那个小数会有一个那种复利的效应嘛。所以它最后你那个 n 值如果很多项的话，那个数字会变得非常非常非常小，会离1非常非常非常远，所以他就会认为这两个 y hat 跟 y 这两个栏会非常非常不像。因为如果完全像的话，后面东西几乎都是1嘛，就像无论它是绿色的1还是紫色的1这种形式，然后乘起来，是不是就会很靠近1？那他就会说哦 y hat 跟 y 很像。可是如果你有一点点不像0.9。你就一直乘0.9乘0.9，最后就会乘成很小很小的小数，那我们就会觉得 y 黑跟 y 不像，所以这个比较激进一点。好，我再一点再讲一遍哈。So basically we use mark product to evaluate how close the y hat and y. So basically for each row, you calculate this likelihood. Okay, if these two values y and y hat are both 0. The result will be 1, right? The green one. If the y hat and y are both 1, which is the purple one, and the result magically is still 1. So basically, when you evaluate a data set with n data points, okay, you simply just multiply, do multiplication, 乘法 among all those n data. So if y and y hat are perfectly exactly the same, so the multiplication would be 1 times 1 times 1 times 1 times 1 times 1. right? However, if y hat and y are not that similar, okay, so for each row, the likelihood is 0.9. So the entire data set, the likelihood will be 0.9 times 0.9 times 0.9, 0.9, 0.9 times 0.9, so on and so forth. So as a result, the value will be very, very small. So that we understand, okay, the y, the actual target, and your model, which is the linear regression model, okay? It's a model, is not that good enough to approximate the actual value, which is y. So the y hat is not good enough. So that is a more aggressive way to drive to drive your model to adjust your parameters so that those parameters can that all the value of y hat would be very, very close to 0 or very, very close to 1, so that when you do the likelihood calculation, it will be close to 1. OK， 好吗？所以就是说，因为这比较激进嘛，旁边差一点就差很多了哈，所以你就要挑选很好的那个那个 A 星 B 星就是那个 parameter 在 linear regression 在 logistic regression 里面，所以它会比较激进一点，所以它会非常的迫使所有的人都很靠近0或靠近1，因为它要使那个 likelihood 这个算出来要很靠近1，等下做乘法的时候才不会落入刚刚讲那个复利的那件事情一直乘0.9，等下最后就不太靠近1了所以它会迫使发生这件事情。Okay, so that is the explanation of such kind of things. This kind of measurement, loss function, only fits to when your target y is categorical. 这种方式的评断方法只适合你的 y 是 categorical data 的时候。If your data, your target y is numerical, and we strongly suggest you use MSE, which is good enough. If your y is categorical, then you can use such kind of likelihood to do such kind of calculation. And this approach is what we call cross entropy. Because in information theory, okay, there is another explanation to compare two different distributions, and the equation of cross entropy is exactly the same as what we use right here. However, they come from different theory, okay, different mathematical theory, but the equation is the same. Okay, so that's called cross entropy. When you use categorical data as your target, you use cross entropy to measure your model. You still try to find the minimum. Okay, when we say likelihood, when we say likelihood, the larger the better, right? 就 likelihood 是越大要越好嘛，在两个y 跟 y 才会越像。So basically, when we find the theta star, we find the max likelihood. However, in mathematics, we usually use partial differentiation. So basically, sometimes we write it in this way. We find the minimum value, but we add a minus right here. 就是likelihood 当然越大越好嘛，所以越大的 likelihood 我们就会找到最好的那个西塔西嘛。可是因为我们在微分，刚讲我们在偏微分的时候，通常是找最小值嘛，很简单，你就加个负号就好了嘛，你就可以找最小值。加一个负的最大值，不就是最小值的意思嘛？对不对？因为这样数学算起来比较方便，但是它没有影响任何定义的事情，它只是计算方便而已。That is, we find the minimum value of minus likelihood. That is just because it is more convenient to do partial differentiation to find the minimum value. So that is the definition is the same. Okay, definition is the same. Okay, we have some mathematical derivation. However, we can skip this part. Okay, we just use this to find the minimum value. Okay, so right here. So we skip this one. If you're interested in how to use the partial differentiation to find the minimum value, you can take a look at this section. Okay. However, there is interesting things we'd like to share with you is like is right here. We will not go into the detail, but there's one important thing you have to know. Take a look at this one, okay? The likelihood, the definition of likelihood is the sum of product, right? Likelihood 的定义就是乘积之和嘛，不，对不起，乘积啊 ，sorry，the definition of likelihood is product， 就是没有和啊，就乘积而已哈，乘积 product。So when you do the partial differentiation, okay, if you do differentiation, product is very difficult to analyze. 如果你对一个全部都是乘积的算式做偏微分，会非常的困难。所以这里有个技巧是这个样子，你就对它取 log， 所以在这边有多加了一个 log 哈。这个 log 是人为加上去的，因为你知道全乘积的东西如果加 log 的话，它就会变成全部的和嘛，啊，如果你还记得的话，啊，就变成全部都是和，全部都是和，在做偏微分的时候，就有些的相似是直接可以删掉的。好，我想你应该知道啊。如果你现在对 x 做偏微分，如果内项里面没有 x 啊，就直接把它删掉啊。啊，如果内项里面只有 y 的话，就全部把它删掉。好，所以这只是数学的技巧而已。好，用英文再讲一遍哦。The definition of likelihood is the product of your data, right? However, to do partial differentiation on a value which is a product is quite complex. So there is a mathematical technique right here. You simply just log it, 就是取弄哈，取弄值。Then the product will become summation. Okay, I think high school mathematics has mentioned these things. And when we do partial differentiation, summation is much better, is much easier than product. Okay, so this is just a mathematical technique. Okay, the definition is still the same. Okay, if you have a large likelihood and you still have a large log it likelihood. Okay, and as the same, if you want to find the largest likelihood, and you can find the smallest minus likelihood. So that is all the same. Okay, so that's the last thing I would like to mention. Okay, so if you have if you interested in how it's related to cross entropy, okay, which is this one. Okay, you can just Google cross entropy or information theory. There will be another mathematical theory talk about how to evaluate two distribution. And after derivation, they derive, okay, how to measure two different distribution, and the equation is exactly the same as we talked about, which is based on the likelihood, okay, which is exactly the same. So basically, we have that likelihood function, right? What to find the minimum value of minus log likelihood function, right? So here it is. So we simply just calculate this value. Okay, we simply just calculate this value. So let's take a look at the original example we mentioned about. Okay, we have a score, we have 20 scans. Okay, we have a score and win or lose. Okay. Basically, linear regression and logistic regression are very basic. So basically, I don't want you to write your own program to implement these mathematical things. Okay, you can simply just use any Python package. Okay, so basically, you just simply use this code, and you can print. Okay, the answer is right here. So how did you read the answer. It's like, okay, I have a z function like this, sigmoid function like this, right? So basically it is y equals 1 plus e minus z, right? And z is ax plus b. And here, the coefficient is right here. That means, okay, z equals this one. The x right here is the score, right? Because in this table we have only one x, that's y, right? Plus b is the intersection, 就是截距 which is minus 15.98. So that is the logistic regression. You use these 20 data points, and the package will help you to calculate all those likelihood and try to find the optimized coefficient and the intersection, 就是 A 跟 B 的值啦，就这样。So next time, let's see. Okay, what is it? That is the original y, and here is the y hat. Okay, so let's take a look at this one. The first game, okay, the actual value is 0, means it loses again because it only get 3 points, right? 3 points right here. So how about our model? Our model output this value. It is a very, very small value. 这个是it is this representation is a scientific representation. Okay, that actually means 这是大家注意看后面这个是这个1的负1次方这个这种负7次方，其实负7次方就几乎就是0的啦几乎就是0。其实负3、负4那种几乎都已经是0的啦。Okay. So that is the y hat. So you can compare the y and the y hat. Okay. For example, for this one, that is close to 1, right? And actually, this value is very, very close to 1 because in actual it is 0.99999, something like that. It's very, very close one. So as we mentioned, if we use cross entropy as our loss function, the such kind of measurement will be more aggressive. So the y hat will be very, very close to 1 or 0. Okay. Okay. So we can cut. So we can draw this shape. Okay. So where is it? This one, right? This one. We use this value to draw this line. Okay. So the orange one is the perfect fit line from the perspective of logistic regression. Okay. So even we can calculate values such like this. So we can find, okay, what is the probability of win? It's 0.5. Okay, so 0.5. So the actual data point right here, and we can know that is 24.8 score. Okay, so if you score 24.8 points, and you have chance to win the game. Okay. So let's take a look at some other example, and we will finish this one. Okay. So what is landing cloud? Landing cloud means we have a bunch of data right here, and of course we have a lot of X right here. That is this is cloud. Okay. So we have for lending, borrow money. Okay. Interest rate, score, loan length, monthly income, loan amount. So those are features that you collect. So every row is a long， 就是每一行是一个借贷，那上面有很多不同的 feature 嘛，啊，上面很多不同的 feature。So it is a table. Okay. So what is the problem we like to discuss? It's right here. What is the probability get along? So get along means y equals 1. In previous example, to win the game is y equals to 1. To get along means y equals to 1. So if you do not get along, then y is 0. So basically, it is still a binary classification problem. The answer is either yes or no, win or lose, get along, not get along. Okay, so you have a data. Okay, the data is right here. Try to clean your data. Okay, $10,000 at 12% or less of less with a IFCO score of 720. Okay, so basically the problem is like this. You can do it by yourself. I want to know the probability of get along y equals to 1 when interest rate larger than 12 under condition FIC score equals to 720 and the loan amount equals to 10K. Okay, so the definition is like this. So basically, if you do this, okay, you can simply just first you have to filter all the information right from the original data. Okay, you have to select the rows which the interest rate is less than 12 and the FICO score, okay, is 720 and the loan amount is 10K. So you have to select your data on your own. So we simply just put all the things in a regression problem. Okay, regression problem. So how did you read these things? Okay, so basically you don't have to do the calculation by yourself. You just ask. Okay, says, okay, would you please help me to calculate all the optimized parameter? So it read as this. So that is logistic regression, right? So here is it. That is the coefficient right here. That means this one, right? That means okay. So basically Z equals that should be much simpler. That is Z value. Okay, Z equals FC score plus times 0.087 plus this value times. Okay, basically it's like this. Okay, so there's a Z value. So basically, in the previous example, we use only one variable, score, right? So you can easily draw the Z shape by using a line, right? However, in this example, we have two variables and one intercept. So how do we draw this figure? We draw this figure in this way, This. It is a surface like a Z shape, but it has two different dimensions. Each dimension represents the Z shape, okay? Or we sometimes use this value, okay? So that is one of the parameter, one of the feature. The other is another feature, okay? So the blue one, okay, you take a look at this one. The blue one means it is close to probability of 0. The red one means it's close to probability of 1. So basically, it is a shape, Z shape. And here, the white line between blue color and red color, it is close to 0.5. So you have to imagine at the right hand side, at the bottom side, there is a very high value of probability, and it gradually, okay, decrease to 50% to the white line, and then decrease to the left up side. So that is a shape if you read this value. So basically, if you input your score, if you input your loan amount, they will tell you what is the probability you get a loan or not get a loan. 好的，讲标，讲完要停了哈。这是一个双变数的问题嘛？刚刚那个问题我们都是只有一个 score 嘛，对不对？一个 score 你只要画一个 z 的曲线就好了嘛，对不对？那现在这个不是，现在这是2个曲线啊，所以你现在想象哈，有一座山呐，啊，它的高度就是 probability， 所以它最高那个山最高到1，最低到0。啊，最高在哪里呢？以这个图来看，就在右下角的地方啊，它是一个很高的高原。那高原呢，会随着你的 FIC score 越来越小，它就会慢慢的往下降。然后也会随着你的 loan amount 越高，它就越来越往下降。降到那个白色那条线的时候，大概就是 50%， 就是你大概有一半的机会得到贷款，一半的几率不会得到贷款。所以那里会有一个坡。可是你注意看哈，这个坡蛮陡的哈。为什么叫蛮陡？因为它从1降到50的地方蛮挤的，啊，蛮挤的。然后再从50的地方降到蓝色就低于50哈，然后一直往左上角延伸到0，所以它是一个如果你看这个白板啊，它在这边是一个很高的坡，然后往下。然后到这个白色线的时候，大概50%，然后到这边的时候，因为这边是0嘛，对不对？然后慢慢的缓坡到这边的50，所以如果你这边有个自己走，这个3D 这样看的话，它是一个很高的坡，然后往下，然后到这边，啊，这样是坡，啊，那你看啊，上面这里有很多蓝色跟红色点，就跟我们在看那个球赛资料一样，蓝色点就是没有得到贷款，也就是输球。红色点就是得到贷款，就是赢球，对不对？那中间会有很多交杂的嘛，我就跟你得25分的时候，有时候会赢，有时候会输嘛，所以这一点这样，就是有的时候你的某一个性质在这里，有某一个性质在这边，可是有时候不知道真审人员怎么做的哈，所以有时候你会得到贷款红点，有时候你没有得到贷款就是蓝点，所以在中间的部分通常跟比赛一样。就是会交杂，所以你的性质是一样的，你的值是一样的，可是有时候你有贷款，有时候没有得到贷款，你得到25分，有时候你会赢球，有时候会输球，所以这边就会隐约的出现一条界限。然后我们现在就是Regression， 就是要求那个坡长什么样子，就这样，好吗 ？OK， let's take a 10-minute break. Okay, then we will continue next topic.